So this was a structure of Pop Quiz 6, which was related to different topics. As we completed question 1, if you have any doubt, question 1. Question 1, okay. The question 1 actually is related to the period 3, element X, Y, and Z. X, Y, and Z are the elements in period 3 of a periodic table. The results of some experiments were carried out with the compounds of these elements. Result of adding water. So if we add a water with X, these oxides, like example, X, Y, and Z, one is forming a hydroxide, one is forming acidic, and X is not forming anything, like no reaction. So just recall the period 3, because I have already shared that the material with you. You have to learn that. For example, if we have a sodium oxide or we have this is mainly related to memorizing the properties of the period 3. So we have a sodium oxide, we have magnesium oxide, we have aluminium oxide. Then we have silicon, the period 3 element, silicon dioxide is there, phosphorus oxide, P4, and O10. And then we have sulfur di or sulfur trioxide is there. If we add water to the oxide, what will happen to the sodium oxide? The sodium oxide and the type of the oxide, it's a basic or alkaline oxide, means like it can dissolve in water, and as a result it will form a solution, like it will dissolve. What about magnesium oxide? Magnesium oxide, if we add, it's a basic oxide, but it is sparingly soluble. Like it is, this one is soluble, this one is sparingly soluble, like slightly soluble. Aluminium oxide, which is amphoteric oxide, so it does not react, like no reaction happen. It does not dissolve in water. So then what about the silicon oxide? The silicon oxide also, it has no reaction with water when we are adding a water. What about the phosphorus oxide? The phosphorus oxide, when we add, it does react, and as a result, like it will dissolve or react, and it will form an acid. And sulfur trioxide also dissolve and it will form an acid. So these two, when it dissolve, it will form an alkaline solution. These two, when it dissolve, it will form an acid. And these two, when it dissolve, it will not form an acid or alkali. Like it does not dissolve, like no reaction happen or occur, the two oxide. So first, when water is added, what could be X? So X could be either, because there is no reaction happen. So what this give an idea that X could be either, which is not reacting. So it might be aluminium oxide or it might be silicon oxide, because aluminium and silicon oxide does not react. What about the Y? So it form a hydroxide. So when we have, like example, and usually when a magnesium oxide is added to warm water, it will form the hydroxide. But here, so this give an idea. So it might be sodium might be there. That is one thing, or it might be magnesium, the Y. And what about forms an acidic? So what is give an idea? It might be phosphorus oxide, or it might be sulfur trioxide. So when we check, X could be aluminium or silicon. So X could be aluminium or silicon. So means either, like two of the options are totally wrong now. Either A can be an answer or B can be a right answer, but it cannot be C or D. Is it clear till this point? The first. And the second point, what is written is Y could be a magnesium or Y could be a sodium. So possibilities are there. Like yes, Y could be. So means we have A and B could be the right answer from the first option, like the first information which is given. Results of adding chloride to the water. Like example, if we add the chlorides, so we are left with only two options, A and B. And now results of adding a chloride to water. Again, you have to learn this. The table is given. I have already shared the table with you. If you add, like example, a sodium chloride, if you add the sodium chloride to water, it will only dissolve. There's a difference between a dissolving and hydrolysis. Like the term dissolving means like it will just break down into ion. Like if you have a sodium chloride, when you add sodium chloride, the sodium ion and the chloride ion will separate from each other and the substance will dissolve. Like the solid sodium chloride break down into ion, that is called dissolving. But what is the term hydrolysis? When we say the term hydrolysis, so the term hydrolysis means when you add a substance and that substance break down the water molecule as well. If a substance which is added, it break down the water molecule into H plus and OH minus, what we call this, we call that as a hydrolysis. Because some substance when dissolve just break down into ions. And when some substance mix or dissolve, they break the water molecules as well. So we call they are hydrolyzed or hydrolysis happen. So you have to learn this, like which chlorides of a period 3 can do hydrolysis and which chloride will only dissolve. So when a sodium chloride is added, it will only dissolve. When magnesium chloride is added, it will also dissolve. When aluminium chloride is added, AlCl3, or you can also say Al2C6, this will do hydrolysis. When you have silicon chloride, so what it will cause, it will also call hydrolysis. When you have a phosphorus chloride like PCl3 or we have PCl5, that will also call hydrolysis. So the first two will dissolve and the other are causing hydrolysis. So when we check, the PCl5, PCl5 and PCl3 both causing hydrolysis. The PCl5, when it dissolve in water, it will form a phosphoric acid and a hydrochloric acid. So now we already we mentioned like this could be aluminium or silicon X. This could be. So again, the second option, when you check this, because of what could be a Y? Y is forming a basic oxide, so it could be sodium or it could be a magnesium. So this also give an idea that either A can be an answer or B. And what about Z? Because A and B we have to check. Now the last part, result of adding an oxide to a hydrochloric acid. So when we are adding, so this one is this, like first thing we identify, because there was a no reaction. So no reaction can happen with either aluminium or silicon. Form a hydroxide means this can happen with sodium or magnesium. Form an acid means this could happen with sulfur trioxide or phosphorus oxide because they're oxides. So P4 and O10. So X could be aluminium. So we identify C or D cannot be an answer because Y could not be aluminium. Then hydrolyze, their chloride hydrolyze. So this can happen for both aluminium and silicon. And this dissolve, so this can also happen for both sodium and magnesium. And this hydrolyze, this can also happen with both silicon and phosphorus. So means this will not distinguish. Now let's take the last one. Result of adding oxide to hydrochloric acid. Silicon oxide is an acidic oxide because it's a non-metal oxide. Non-metal oxide cannot react with acid. So there is no reaction. But aluminium oxide is an amphoteric oxide. The amphoteric oxide can react with both acid and alkali. So it gives an idea that this element should be aluminium. Why? Because aluminium oxide can react with a hydrochloric acid, but silicon oxide cannot react with a hydrochloric acid. So this confirms that X should be aluminium. So if X is aluminium, so which is the right option? Means A will be the right option. Still, form chloride, this can happen for both sodium and magnesium oxide. Like if I have a sodium oxide, I react the hydrochloric acid, or I have a magnesium oxide and I react the hydrochloric acid, this will give the same result. It will not make difference. Is it clear? The table I have shared no, about the properties, I will tag that on the group, that which I refer. The last week I have shared the notes, the chapter notes. In that one you find. I just take that file so you can see now. Question 2, any doubt? Question 2. Question 3. Question 2, okay. A solid period 3 element Q react with oxygen to form a compound R. R is added to water and the pH decreases. So when the pH decreases, it means it is an acidic oxide, okay? Because the pH can only be decreased when it's an acidic oxide. So what are the acidic oxides we have? We have the silicon dioxide, the acidic oxide in the period 3. We have phosphorus oxide, the acidic oxide, and we have a sulfur trioxide. That's also an acidic oxide. Now, they said, what could be the empirical formula of R? So Q, we identify Q as a non-metal. Like example, it might be QO2, it might be Q4O10, or it might be QO3. Q can be silicon, Q can be phosphorus, Q can be sulfur as well. Now, what is if Q was a silicon, then what is the empirical formula? It should be QO2. Is there any option of QO2? There's no option. So means it cannot be silicon. Like there's no option of QO2. Then Q can be phosphorus. If Q was a phosphorus, the formula of the phosphorus oxide is P4 and O10. So what is the simple empirical formula? The simplest ratio between 4 and 10. The simplest ratio will be 2 and 5. So means the empirical formula could be Q2O5. So Q2O5, so it means B will be the right answer. Or empirical formula can be QO3, but there is no QO3 option, so we are left with only Q2O5, where Q is the phosphorus. Why not C? Because C is representing a molecular formula. The empirical formula is always the simplest ratio. So 4 and 10, the simplest ratio between 4 and 10 is 2:5. So whenever we have an empirical formula, the empirical formula always represents the simplest ratio between the atoms which are present in a compound. So Q4 and O10 is a molecular formula, but not the empirical formula. The silicon oxide will have the same molecular and empirical formula, but phosphorus oxide will have different molecular and empirical formulas because P4O10 can be simplified as 2:5. In question 3, a metal T react with water to form a colorless solution. A white precipitate was produced when it is mixed with sulfuric acid. Whenever a sulfuric acid is added to this metal, like metal T was there, and it is forming a sulfate. So whenever a sulfuric acid is added or a sulfate is forming, it is forming a white precipitate. So what this give an indication, which metal should be there? It means it should be a barium, because barium sulfate is insoluble. So magnesium sulfate, most sulfates are soluble except calcium, barium, and lead. So this cannot be magnesium. Potassium and sodium are soluble. So it's left with only barium. This is about the solubility table. In IGCSE also you have studied that all nitrates are soluble. Most chloride except silver, mercury, and lead. Most sulfates are also soluble except barium, calcium, and lead. So only sulfate, like the option we have barium as a sulfate which is insoluble. Rest all of them will form a soluble sulfate. Question 4, any doubt? In question 4, you have to first write the balance equation for thermal decomposition of the nitrate. When a calcium nitrate is decomposed, it will give calcium oxide plus nitrogen dioxide plus oxygen. That's the equation for thermal decomposition. And the equation must be balanced. Then you will use the ratio after writing a balance equation. We have the ratio is 2:4, or ratio is 2:1, I guess, because oxygen is there. What volume of oxygen is produced? So ratio is 2:1. So if we have 0.5 moles, this will be X. We cross multiply. So after cross multiplying, if 2:1 is the ratio, 0.5 will be 0.25 moles. After getting 0.25 moles, we multiply by the molar volume, which is 12. So as a result, 0.25 multiplied by 12, so we'll get A as a right answer. So first you have to write a balance equation for the decomposition of the nitrate, the thermal decomposition of a metal calcium nitrate, and then use a ratio. Question 5 and 6, any doubt? In question 5, remember the reactivity as we go down the group, it increases. Like we have beryllium, then we have magnesium, we have calcium, strontium, and barium. As we go down, what will happen to the reactivity? The reactivity increases. When we compare the solubility of their hydroxides, that also increases, it becomes more soluble. So they mention L react more vigorous with a dilute hydrochloric acid than N. So we have the elements are there. We have L, M, and N. L is reacting more vigorous than N. So it means L should be below N. N should be above. Then the hydroxide of M is more soluble than N. So if the hydroxide, like first thing we identify that, as I mentioned, L is more vigorous, like the reaction increase, so L should be bottom and N should be there at the top. Then when we compare the solubility, the M hydroxide is more soluble than N hydroxide. And solubility increases as we go down the group. So M is more soluble. So if M is more soluble, what could be, means M is below N. So which could be the identities of L, M, and N? So means L should be the more reactive, like this is the order. L is a more reactive, and we have these elements like barium, calcium, and strontium. So what this give an idea? we have the three elements are there like this, and we got the series as L, M, like N, M, and L. So what is N here? N should be calcium. What is M here? M should be strontium. And what is L here? L should be barium. So which one it matches with? It matches with option B. Is it clear, this one? Because as we go down the group, the reactivity increases and the solubility also increase down the group. In question 6, the table shows some reactions of a white compound G. When we add a silver nitrate to G followed by aqueous ammonia, a white precipitate is formed which does not dissolve. So if a white precipitate form and does not dissolve, remember one thing, as I mentioned, the color of the precipitates, like example, chloride, bromide, or iodide, practically we say them like we say chloride is white, bromide is cream precipitate, and iodide is yellow. But when you're using that in a lab, they all appear to be the same shade. It's hard to recognize is it a chloride or a bromide or iodide. So even for example, if it is written white, and it's not written the color of the precipitate, it's only written a precipitate form which does not dissolve. So which precipitate does not dissolve in ammonia? So two of the precipitate which does not dissolve, as they did not specify, it's written only aqueous ammonia. So we will consider it's like a dilute ammonia. So the precipitate which does not dissolve, it will be bromide or iodide, which does not dissolve. In concentrated ammonia, bromide will dissolve, but if it is written aqueous, you will consider that as a dilute as well. So it means it might be bromide or it might be iodide. So it cannot be this or this. So either B can be an answer or D can be an answer. Next is when you warm a solid G with a sulfuric acid. So iodide ion, remember, and as a result, it produces a hydrogen sulfide. So remember, as we discussed, the reduction power of these halide ions, if bromide ion, if a substance contain a bromide ion and it react with sulfuric acid, the product will be bromine, the product will be sulfur dioxide, and water will be there. But if it is iodine reacted with sulfuric acid, the product will be iodine, sulfur dioxide, or product might be iodine and sulfur, or the product might be iodine and hydrogen sulfide. So because when we warm this solid G with the sulfuric acid, we get a hydrogen sulfide gas. So it means it is an iodide ion present rather than the bromide ion. That's why D is the right answer. Is it clear, this one? Question 7, 8, any doubt? In question 7, under standard condition, which statement is correct? Bromine can oxidize, chlorine can oxidize bromine. That's right, because chlorine is more reactive. The more reactive halogen displaces the less reactive halogen from its compound. So chlorine is 0 here, become -1. So 0 become -1, this changes a reduction. And -1 becomes 0, this changes oxidation. So if a reduction happen, it means the substance is an oxidizing agent. If a oxidation happens, substance is a reducing agent. So which statement is correct? Because chlorine is more reactive, the more reactive halogen can oxidize the less reactive halogen. So chlorine can oxidize the bromide ion. That's correct. Because it is oxidizing bromine, the bromide ion is -1, it becomes 0. So it is oxidizing, that's the right statement. So always the more reactive halogen displaces the less reactive halogen from its compound. When a solid potassium bromide react with a sulfuric acid, which substance does not form? So which of the substance does not form, as we just discussed now? Like example, when a potassium bromide react with sulfuric acid, first there will be an acid-base reaction. It will produce potassium hydrogen sulfate plus hydrogen bromide. So HBr is produced. This is produced. Then this hydrogen bromide, which contain a bromide ion, react with sulfuric acid. So it will form bromine and it will form sulfur dioxide. So bromine is also formed sulfur dioxide. What this does not form is a hydrogen sulfide. So D is the right answer. Because bromide ion is not good reducing agent as compared to that of iodide ion. Which equation does not represent the disproportionation of reaction, means in which the same element is oxidized or reduced? So you have to write the oxidation number. Chlorine is 0 here. Hydrogen +1, oxygen -2, so chlorine should be +1. Here chlorine is +1 and hydrogen +1, chlorine -1. So here chlorine 0 become +1, it is oxidation, and 0 become -1, reduction. So this is a reaction in which the same element being oxidized or reduced. When we check the second one, chlorine is 0 here. Each oxygen is -2, so 3 oxygen will be -6. Potassium is +1, so chlorine should be +5. Here, chlorine -1 and +1. So 0 become +1, oxidation. 0 become -1, so reduction. So same element being oxidized or reduced. So this is also the reaction in which the same element oxidized or reduced. So this proportionation reaction. When we check this one, each oxygen is -2, so 3 will be -6. Potassium is +1, so chlorine is +5. Here +1 and -1 and 0. So +5 become -1. So this is a reduction, but there is no oxidation happen. So this is a right option, that in this one only reduction happen. There is no oxidation happen for the chlorine. Like the same element is not being oxidized or reduced. Only reduction happened, but not oxidation. Question 10, 11, any doubt? 10 and 11. In question 10, how does the addition of the catalyst, remember the Maxwell-Boltzmann distribution curve? So this is a curve. So if we use a catalyst, like without a catalyst, activation energy is higher, but with a catalyst, activation energy is lower. So does it affect the shape of the graph? So there is no change through the shape of the graph. It only what happened without a catalyst, the activation energy will be high, but with catalyst, the activation energy will be low. So there is no shape. So there is no change in the shape with the catalyst. With the change in temperature, yes, it changes the shape. With the change in pressure, with the change in the concentration, yes, the total area will change, but not with the catalyst. Then this is a reversible reaction. What is the effect of decreasing a temperature? This is an exothermic reaction. For an exothermic reaction, if we increase the temperature, what will happen to the equilibrium? Equilibrium will shift toward the left-hand side. And if we decrease the temperature, equilibrium will shift toward the right-hand side. And what happened to the rate of a reaction? Rate of a reaction is directly proportional to temperature. So if you decrease the temperature, the speed or the rate of a reaction will decrease. Rate of a reaction does not affect like it is forward is endo or exo. The rate of a reaction is proportional to temperature. So rate of a reaction will decrease, and the equilibrium position, because we are decreasing a temperature. So if we decrease the temperature, equilibrium shift toward the right. So we'll get more product. That's why B will be the right answer. So decreasing a temperature for exothermic reaction shift the equilibrium towards the right, but decreasing a temperature will also slow down the rate. or speed of a reaction. In question 12, a sample of a 50 cm cube ethanol is burned completely in 200 cm cube of oxygen. All volumes are measured at 400 Kelvin and 1 atm. What is the total volume of a gas when the reaction is complete? First, we'll find which one is a limiting factor or a reagent. The ratio is, the gases are there, so we can use a mole ratio. So ratio is 1:3 between oxygen and ethanol. So 1:3 is a ratio. If I have 50 cm cube of ethanol, how much oxygen I need? X cross multiply. So for a complete reaction, we need 150 cm cube of oxygen. We need 150 cm cube of oxygen, but we have 200. So it means oxygen is an excess and the ethanol gas is a limiting. So we need the total volume which is left. So the total volume which is left will be the unreacted reactant and the formed product. So how much reactant will be left? This will be used up completely. This is 150 is used up out of 200. So how much is left? 50 cm cube. Then the formed product, because carbon dioxide and water both are in a gaseous state, to know how much product is formed, we always use a limiting reagent. So we'll use C2H5OH and the carbon dioxide ratio. So the ratio between them is 1:2. So if we have 50 cm cube, how much carbon dioxide will be there? X cross multiply. So it will be 100 cm cube of a carbon dioxide. And C2H5OH and the water, the ratio is 1:3. So if you have 50 cm cube, how much water will be there? X cross multiply. So we got 150 cm cube of water vapors. So what is the total volume of the product? The gaseous product, 100 plus 150. So that is equals to 250. So 250 cm cube. $250 cm cube is there. And 50 cm cube of the, like 250 cm cube of the formed product and 50 cm cube of the reactant. So we need the total volume here. So how we can work out? We just add them. So that's why D will be the right answer for this. Even though the question, they mention all volumes are measured, because all volumes are at same temperature and pressure. That's why we can take a ratio. If the temperature or a pressure changes during the experiment, then we cannot take the ratio. But here, because all the volumes are measured at the same temperature and pressure, so we can simply use the ratio here. Instead of using the equation PV is equals to nRT. So this was the pop quiz. The structure pop quiz and the weekly homework I'll discuss in the next session. Any question or doubt related to the class today?